Hi, everyone. I'm Hari. I lead the content and community function at Kinetica. Today, we'll be discussing how to set up the backend, essentially the analytics for real-time location intelligence apps. Um, so yeah, let me go ahead and share my screen so we can get started. So Kinetica is a database for time and space. So we specialize in time series and spatial workloads. And it's pretty easy to deploy Kinetica for free. So there's the cloud version, which you can just click here, and it takes about a minute to sign on, and it's free to use. And there's also the developer edition, which is a free forever personal copy of Kinetica. Right? So that's what I'm using for doing this demo. So let's head over to Workbench, which is the interface for Kinetica. So this is Workbench, and this is sort of the home screen of Workbench that you would see when you log on. And so I have a workbook set up for this demo, so I'll open that. So let's say Spatial Analytics. Um, so let's start by discussing what we mean by real-time location intelligence, right? So let me actually blow this up so that everyone can see. Um, Okay. And so real-time location intelligence is essentially the ability to gather and analyze and act on location-based data in real time, right? So it's not that we store the data and look at it in a week or a day's time. It's, the data is coming in. How do we analyze and make sense of it and take action on it in real time as it's coming in, right? So there are a few capabilities that are important for it, but one of which is the ability to connect to streaming data sources and ingest that data really quickly. The second is really fast spatial analytics. So you need to be able to execute really complex geospatial queries in real time, right? And the backend side of that is also being able to extract the data out of the database really fast into downstream applications. So we'll be demoing all of these aspects in this short demo. So I'll show you how to connect, how to do the analytics, and how to stream events out of Kinetica. So the first piece is connecting to data sources. So these set of queries, essentially, they connect to a data source, a Kafka topic, right? So we have a few Kafka topics that we're connecting to. One of them is vehicle locations. Another one is a New York City taxi data set that we'll use for some other analysis, right? So if I head over to Confluent, you can actually see these messages coming into, and I can show you these messages coming into Kafka, right, into this Kafka topic. So this is the data that we would be ingesting into Kinetica, right? As you see, these are coming in, a couple, 2 to 3 records per second is the pace at which this is coming in, right? So each record has each message in this topic has the X and Y coordinates and ID, which identifies which vehicle these coordinates are coming in from, right? So we'd be using this sort of GPS data for the demo. And there's also an associated timestamp with it, which tells you when that was recorded, right? So we'll soon see how that looks on a map, right? So let's plot this. And now we should start seeing these records populate into this table here, into this, see, on the map. So as you can see, it's already here. And it'll keep updating this to show you the most recent version, right? So you can see those dots moving. So these are, so we have sped up so this only emulates real-time data. So we have sped up the data. So it's actually what is being visualized here is this table here. So I've created a materialized view, which identifies all truck locations in Washington, D.C. area that we are generating the data from Kafka for the last 2 hours, right? So this is the entire last 2 hours worth of data which is being shown here. And so the topic itself is set on loop, so it'll keep repeating this route over time, right? But it's a very good way to demonstrate our routing capabilities and also some of these spatial capabilities that we'll talk about today. So that's one data set that we'll be dealing with today. The second one is these fences table that I've set up myself, which pretty much looks at. Let me refresh this. So these are actually. Let me also zoom in a bit more so that everyone can see the code clearly. Um, so these fences outline certain landmarks in DC, right? So these are all the different landmarks that are in DC that I've sort of outlined with these polygons. Um, So the next so that's the fences piece, and we'll look at some for these other worksheets in this workbook. We'll look at different ways in which we can perform spatial operations using the tracks data that we saw just now, which is this one, the trucks, right, moving through DC, and these fences, right. So we're interested in things like intersection, whether some a particular GPS coordinate is contained within these fences, so or is within a certain distance, right. Those are the things that we want to identify in this workbook. Another piece of data that we'll look at is the New York City taxi data, which people are probably familiar with. This is a very commonly used demo data set. So you can see this is also streaming in really fast, and you can actually check on these tables here. Um, so taxi trips, right, in this, yeah. So despite the fact that I'm hosting a webinar, we've sort of managed to pull in 36,000 records in no time, right? So it just came in right now. All of these are coming in from Kafka. So that sort of demos are really fast data ingest capabilities, right? So let's jump into the actual spatial analytics part. And so this sheet, I also have we've produced a playlist for geospatial analytics using Kinetica. So that's accessible via the workbook, but also you can watch it on YouTube. So if you wanted to watch it here, you can watch it here, but you can also access it via YouTube. And these are being rendered, like all of these are being rendered using. So this one, for instance, is an HTML block that I've embedded this playlist in. And these are all possible within the workbook, right? So you can add these blocks inside the workbook and do your analysis. So let's take a brief moment to talk about Kinetica's spatial capabilities, which is all centered around the ST functional library, right? So ST functional library is a very popular library that is, if you've used PostGIS or anything else that uses the ST functional library, you're familiar with Kinetica's spatial capabilities. So we offer almost a wide range of ST functions, along with some custom functions, which you'll see in the entity tracking piece, which are not available elsewhere, right? So you can think of these ST functions into three broad categories, right? One is to compute attributes. So let's say I have a polygon, I want to calculate its area or perimeter. So those are computing attributes. The second is to identify spatial relationships. So if does a line segment intersect a polygon? Does a point fall within another polygon, right? What is the distance between two spatial objects? And the third broad category is constructing geometry. So what is the centroid, maybe a buffer around a particular point, combining two different polygons, dissolving intersecting polygons into a single polygon. So we'll see some of those very quickly in these, right? So let's actually do one attribute computation, which is so here I am just calculating the area of all the fences in the table, right? So it says Lincoln Memorial. So you can see all the different sort of fences and their associated areas. And fences, again, is just to remind everyone, is this is describing the area of all of these polygons, right? That's what it's doing. So the second piece that we talked about was identifying spatial relationships. So here, if I run this, here it's just checking whether there are in the fences table, are there polygons that intersect with each other, right? So we notice, Lincoln Memorial and Vietnam Memorial intersect with each other. Washington Monument and Vietnam Monument Memorial intersect with each other. So these three sort of intersect with each other, and you can see that in the map as well. So if I go down. You can see that the way that I've drawn these sort of intersect with each other, right? And we can sort of, further confirm this if we dissolve all of them. So in this last piece, we're going to construct a geometry, which is like the dissolved version of that, right? So I've dissolved all the WKTs in the fences table. So anything that is touching each other will be merged into a single polygon, right? So, and you can see that that's happened here for the ones that were intersecting. But none of this is demonstrating real-time capabilities. This is just a primer to show some of the broad capabilities, right, of the platform, because this is possible with any kind of database that you might work with that has the ST functional library. So let's look at so now let's look at some of the implementations, right? So how you might implement this in a real-time location intelligence app. So the first thing that I want to explore is, again, this is something also that most databases should be able to do, which is like a general standard spatial filter. Here I'm just filtering out the polygons which have an area greater than I think 500,000 meters square, right? So there are only a few which are showing up. The others which were here in this area are not showing up anymore. Next, let's look at, okay, now let's move on to some of the more advanced capabilities that we offer, right? So the first thing that we look at is a spatial join. And so this spatial join is set up via a materialized view that is set to refresh on change. And so I think that's important to know because as you know that the recent locations table is receiving all of these new messages, right? Look at all those messages that are coming in, and these are being ingested into Kinetica as well. So anytime a new message or a record hits this recent locations table, this query has to be updated, right? So it's pretty much being updated continuously. That's the point, and it's executing a spatial query, spatial join, where essentially it's combining all the tracks data where the distance of that tracks data is within 200 meters of a fence. So if a particular truck location is within 200 meters of a fence, then identify that record for me. And that's what I'm asking it to do. And let's refresh this map. And you can see all of the intersections populating here, right? So anytime there's a new intersection, that'll also populate here. And if I go in closely, I can see those points inside these fences, right? So it's sort of highlighting. And here, like you can see, this is not intersecting, but this is within that 200-meter distance in the middle, right? If I go here, like it's this point is not intersecting, but it's within that 200-meter distance, and it's identifying that all. And you can see that it executes really fast as well, right? So there's no lag in how fast it's executed. So that's well and good. Now let's take this another step forward, which is to do a geofencing. So geofencing here, what I'm doing is I'm adding an additional criteria, which is I'm not interested in all the intersections. I'm interested in what's happened in the last 5 minutes, right? That's the question that I'm asking. So this just keep in mind that we are dealing with real-time data, so it might be that this doesn't trigger immediately, but we'll show. So see, there's no immediate sort of record which is pulled out because there's no intersection that happened 5 minutes back, right? So that's just a factor, because we are running this in real time, right? So if you wait for a bit, this should show up. But another way to do this is it's sort of pointless to stand here and wait for this to update, right? You can't just stare at this forever hoping that an intersection happens. So instead, what we can do is monitor this particular fence that we set up, right? So let's actually look into this query a bit more. So the fencing events query, what it's doing is that it's again looking at whether, so it's using the xtxy_contains function to see if a particular point is contained within a fence. So if a truck location falls within a particular fence, then we want to extract that record. It's also adding an additional criteria, which is that the timestamp in which that GPS coordinate was recorded was within the last 5 minutes, right? That's the two criteria that we have. So once this view set up, this is also set up as to refresh on change, right? So it's automatically updating itself with the new truck location. So anytime there's a new truck location, it'll re-execute this and try and find whether this criteria is satisfied, right? So once it's set up, what we can do is set up an alert, right? So here what I've done is I've set up an alert text, and we then sort of so this is a second view which is pointing to this geofencing view and extracting just a couple of columns from that table, right? So I want an event text and a track ID from that previous fence view that we set up, and then streaming that particular view into a Google spreadsheet, right? That's what I'm going to do. So anytime there's a new event, that should be recorded here. That's the point. Okay, so now if you keep, this is whenever there's an intersection, that'll show up in this table. That's the whole point of this. And just to talk about the stream a bit more, the stream can be set up with just a destination webhook, or it could be a Kafka topic, and there are multiple other JDBC sources. So there are multiple other sources that a stream can point to. A stream essentially is just setting up a way for Kinetica to send messages or send events to other data sinks. Right? That's the whole point. Um, okay, so that's set up the stream. So we'll come and check back on it in a while to see if there's some other events which are added here. Right, this one was there from earlier, so we can ignore that. Um, so that's sort of broadly the spatial capabilities that most people are familiar with, right? So Kinetica also adds one other layer on top of this, which is around entity tracking. So one issue with the way that these geofencing events are set up is that remember this event that we saw in the spatial join, right, um, where it was close to the WKT, but it was not within, right? So what if there was a point where this it recorded a GPS point here, it went inside the fence and came out, but there was no GPS data which was generated while it was inside the fence, right? So it will miss that particular event. So one way to address that is using tracks. So what tracks essentially do is that when you have a series of geospatial points, spatial points, it interpolates the path between those points. So in this case, as you can see in this animation, right now there's no geofencing, but fence event detected. But once you interpolate, we can infer that there was a fence event that occurred, right? That it entered that fence and then exited, despite the fact that there was no spatial coordinate within that fence that was recorded. So Kinetica allows also out of the box comes with those features, right? And it comes with some convenience functions around tracks as well. So here we are using the track length and track location to identify, hey, what is the length of each track, right? How many kilometers has it traveled, and what is the duration of each track in the data, right? So it's sort of run that summary statistic and given that really quickly the results. And next, we can also use the st_track intersects function to identify these events, right? These fence events. So here again, remember that it's interpolating, right? So let's run this. Okay, so see, it actually did intersect with one of the. See, this might be. So if you see, there's an intersection event that's happened that it's recognized. See, and I think this might have happened just now. Okay, so that's sort of showing you how the many different ways in which you can set up interfencing geofencing events in Kinetica, but this is probably the most accurate version for doing fence events in Kinetica. So using the st_track intersects function. The other features as well that come with tracks. The another one that to highlight is the proximity one. So proximity one again is just saying are there two vehicles or two tracks that came close to each other. Here I'm really setting spatial distance, xy distance of 200, a time distance of 1 minute, right? That's so 200 meters and within 1 minute of each other, right? So did these two tracks come within 200, their GPS coordinates come within 200 meters of each other within a minute interval. And so we identify again a bunch of these tracks which came close to each other, which sort of you can tell if you look at the tracks as well. There is tracks which come close to each other, and that's what it's identifying, right? Some of these tracks sort of come really close to each other. Those are the points that it's sort of identifying in that view. Again, all of these can be piped down to the same way that we set up this stream. It can be piped down to some other downstream application or some interface which can then, do downstream analytics in real time using this, right? Let's actually see if any spatial events are being triggered here. Not yet. So we still have to wait because fencing, this query works slightly different from entity tracking, right? So it's sort of illustrated here in the way that the track sort of interpolates and calculates that fencing event. And this again, remember, it's also looking for within the last 5 minutes. If it doesn't happen in the last 5 minutes, it doesn't care about this. That's the same with this track function as well. The last piece that I want to talk about before we close and move to questions if you have time. Okay, I'm almost running out of time. So is binning. So one other thing that you want to do often with particularly with large amounts of data when you're dealing with and so if you're dealing with a stream like this, right? So where messages are coming in all the time, you want to be able to also aggregate really quickly. So binning is one way that you can do that. And Kinetica provides these. So there are multiple ways binning functions that are provided in Kinetica. The standard ST functions that you would expect, but we also provide the H3 binning functions that came out from Uber. So Uber uses this for most of their ride sharing application, right? So here the basic idea is that they've sort of split the whole world into these different hexagonal bins, and every bin has an index associated with it and a resolution associated with it. So we can calculate the index first, and then after that we can summarize on that index to bin the data. So it sort of looks like this, right? So you can see the map, and let me zoom out a bit to regular view to see this clearly. And let me configure this and update and see. Okay, update. Yeah. So this is a very quick view into how we can bin data really effectively. And remember, like we're running this also, I'm running this on my local machine, right? I'm not using any, if you see this is localhost 8000, I'm running this using my personal laptop. It's not a cloud server located somewhere. And this is the free version, that the kind of performance that you would expect if you were trying this on your own, right? So I'm not, running this in some expensive hardware right now. And just to highlight how much data this is crunching, right? It's crunching a lot of data in no time. Um, and so you can use binning to explore other functions as well as set up some tasks that you could explore on your own if you wanted to. And this workbook is also available here in our GitHub repo. So if you go to Spatial, this workbook is available on that under that folder. It's taking a while to load for some reason, GitHub. Yeah. Oh, and there we have some events which are streamed in, right? 4 is at DuPont, 4 is at DuPont. So that's an illustration of how the streaming capability. So if I go to here, hopefully it's still there. Yeah, there. Nice. So those events just happened as we were talking, and we didn't have to stay here and look at it. It just pops up here, right? So these were new events that were triggered just now during this webinar. Okay, so that was a summary of our of Kinetica's spatial capabilities and real-time spatial capabilities. So I'll stop sharing so people can ask questions. So I see a few questions on our chat. So is the system works indoor? Indoor meaning I mean, yeah, it works indoor as in, yeah, yes, I have it works indoor. It's run on a computer. I don't fully understand the question. Maybe they could clarify that. What do they mean by indoor? And I'll come back to that. How efficiently can this code in Kafka be used while monitoring the climatological and meteorological parameters? It can. This works, like you would expect with any other spatial database, and it'll work far, as you can see, much faster than all of the other spatial databases that you might have used. And yeah, we can work with all of those. So you can pretty much look at all the ST functions that we support on the documentation side. Let me actually pull that up. Oh, docs. So if you go here and look at all the functions, this is a list of all the functions that we support. It's easy to access and sort of see what you can do with that. And all of these are vectorized, so all of them you can expect them to expect really fast speeds in execution. Introductory link to the geospatial analysis. Yes. Which is also here. You can watch it here if you wanted to, but let's not do that. But you can also open that in YouTube, and I'll share the link. Okay. Coding for this on R based Python. So we have a Python API. It is possible to connect to Kinetica as a PostgreSQL database. So we have a PostgreSQL wireline. So most of these functions will also work via that interface. So you can connect from R, where Kinetica is set up as a Postgres client, right? So you can issue these queries from R using that. Python, we provide a standard Python API as well. And you can find the details to connect to that to a Python, you know, interface using this. So So yeah, we support both Python, R, we support JavaScript, we support a lot of different languages. Are these codes can be generated using Kinetica? Yes, all of this is within Kinetica itself, right? So everything here that I showed you is are these are all custom functions which have been vectorized essentially, so that they run really fast, and they're all set up in Kinetica. They're all custom functions. So it's not, Kinetica was built from the ground up. So it's not like built on top of something like Postgres. It's built from scratch. Um, yes, it can be used. So it's a non-GPS system. Yes. Kinetica is a non-GPS system. It supports general OLAP queries as well. And so not just ST function library. It has a wide range of capabilities um, in SQL. So um, yeah, it supports non-spatial queries as well, and non-GPS data as well. Did I miss any questions? Um, and it's easy to try out. So anyone can go try this, right? So setting Kinetica up is really, really easy. You can go try the try free button and it'll immediately land you into Kinetica. So, and signing up takes, you can use your Gmail or whatever you want to sign in to Kinetica really easily. Um, any other questions before we close? Prediction events. Execute. So I'm assuming, so we have some basic prediction capabilities, so we can run regressions and detect outliers and things like that. We also support window functions, and you can do a lot of predictive analysis using that. But one other key way in which we support, and I'm if you I'm wondering, I'm guessing that's something to do with ML. Is that we can do feature generation using Kinetica. So all this high speed that you saw in terms of generating features, that can be generated in real time in Kinetica, and they can plug into machine learning model for further predictions on that. Is Kinetica available under freemium version? There are, it's totally free to use, but there is also, if you want to deploy, a, in a production cluster, then we charge money for that. But for personal use, it's free. Um, it's not, Kinetica is not open source at the moment, although there are talks in the future to make it open source. It's not open source at the moment, but but it's free to use fully. Other systems or API similar to, so other people who support ST function libraries would be Google BigQuery is one, PostGIS is one, right? And yeah, those are the top ones that people might use at the scale that we're talking about, right? We are thinking about not just small scale data, we're thinking large scale data, where it's just say production systems that are sending in a lot of different data. Heat maps can be generated in the workbook as well. Those are all generated inside Kinetica, right? So all the maps that you saw here, these are all generated inside Kinetica, right? This comes with Kinetica. And this workbook is inside Kinetica, right? So this is how you interface with the database, and all of this comes with the database. So you can add, just to give you a sense, you can add SQL blocks, you can add text blocks, image blocks, HTML blocks, and map blocks inside Kinetica. And these are the ones that you saw here. These are map blocks. This heat map that you see here is also a map block. And it's pretty easy to configure these as well, right? So heat map is one. I can do raster, class break. Depending on the data, I can change these. Oh, sorry, I wasn't sharing my screen. I was talking through the screen without really sharing it. But all of the blocks are generated inside Kinetica. Yeah, everything that I showcased just now was all done inside Kinetica. There was nothing external. All right, if there are no more questions, I'll close. Please go ahead and try this out. It's very easy to set up, right? Particularly Kinetica Cloud is just a couple of minutes to set up. So if you go to kinetica.com and hit the try free button, it'll immediately launch. So yeah, go ahead and try that. And I've also uh, I'll also post the link to the workbook itself, or it might be shared after the call, so that you guys can access whatever code that I had demoed, right? So this is free for everyone to try. That same workbook that I showed, everyone can try that on their own. All right. Thanks, everyone. Yeah, that's it from my side. Oh, I see one more question pop up. Are there any, before we close, okay, are there any evidentiary information where Kinetica has been used to generate heat maps? Evidentiary information. Like this, will Kinetica be able to predict certain geofencing events based on availability, or maybe predict heat maps at a certain. Yes, it can do all of that. So if it can do real-time sort of map generation, all of those maps are updating in real time, right? So they're set to refresh and update and show you the most recent version of that data. And you can generate those views that the maps depend on your own as well, right? So you can say, hey, I want a custom view that captures certain spatial characteristics. That you can do as well. Um, yeah, so I mean, unless I share the screen, the all the maps that you saw, there was a heat map in there as well, the taxi data. That is inside the workbook. So if you try this out on your own, you'll be able to generate that yourself and play around with it. Any other questions before I close? Okay, we are slightly over time. So thanks everyone, and let us know if you have any other questions or feedback. Thank you.